Over here on the metal fabrication side, we use the Lincoln C300. Very similar to the S350, but a little less amperage. First thing you're going to want to do is make sure that it is plugged in. We do run a 4-prong plug over here. This is 460 volts. It does twist to the right for locking, left to unlock. I'm not going to unplug it because it is difficult to plug in and out. So make sure that is in there securely, and make sure the cart does not interfere or ram the plug, otherwise it could get damaged. So very careful in this area. Over here we run the Blue Shield 6. This is 90% argon, 10% CO2. So for this process we're able to run the pulse. This is the valve to open up the gas. It's the smart top here, very common now with most gases. And these come in at, when they're new, about 2500 psi. Also there's another gauge right here you can gauge to make sure. As soon as you're down into the red, start to monitor that, and then we'll change that out. Okay. Next thing you want to do is make sure everything is plugged in up front here correctly. This switch right here, this plug will be for the switch on the gun. That'll be this one over here that operates the wire and energizes the wire and drives it. Over here you want to make sure you're plugged into the negative side for our ground connection. Make sure your ground connection is working correctly. You got lots of spring in there so you get good contact. Over here this is for the TIG welding, and then this is on the positive side for the ground for different applications for TIG welding. The drawer down below here does have a stick electrode holder in here, and generally we do not use that because it's just too smoky over here on this side, so we just like to run the hard wire. Also make sure your gas nozzle is clean and is in good working order. Make sure your tip is in good working order as well. You don't have spatter or build up in this area. You have to do, make sure you're using your proper tool for removing your nozzle or cleaning your nozzle and your clipper for this MIG gun. A lot of information is found underneath here as well for when you're operating this machine. So the interface up front here, it's got lots of information to read on that, and we'll be going over that as well for all your different modes and typical wire feed speeds with typical thicknesses over here. Over here, your spool here, you're going to want to make sure this retaining nut on here is on so your spool does not fall off. Also, you're going to want to make sure your tensioner here for your drive wheels is set correctly. So for gas metal arc welding, we're going to be using number 4 here. So make sure that's just screws here and then number 4 there. You're going to want to make sure you've got the correct drive rolls. These are going to be a V style here, and that'll be for the top and the bottom. You want to make sure your wire guide is on there correctly and your wire is guiding through there. So that's where most problems are in this area. And then down over here, make sure this is plugged in again for the remote switch here for the gun. The gas here is for the TIG here, and the switch over here will drive the wire to go up, and you can purge the gas going down. Okay. Instead of using the trigger, which energizes the wire as it comes out, so you don't need to do that. So driving the wire is good when you're putting on a new roll or when you're changing your flow of your gas up top here as well. So as you're changing your flow here, you can change your flow from here, and we're looking for about 25 cubic feet per minute. So just adjusting the flow. So looking for the ball on that. Okay, that's inside the machine here. And from there, make sure that's click close, so nothing gets in there. From over here, we're going to turn the machine on. We got a a silicone dust cover here. Make sure not to pull and rip this off, please. And then you can tell we got the software that we're running here for the C300. We'll come up here in just a moment. And it's takes a little while to calibrate, and then there's the welding software, so you can tell how up to date that is just right there. So for the modes that we're going to be running here, generally we're just going to be, because we're going to be running the mixed gas, we're going to be running the pulse, so number 12. There is another couple options that you could run as well, which would be number 5, which is just a standard CV, which runs most wires. But let's go up to the pulse here. We're going to do the pulse, and we're going to do number 13, rapid arc. So the difference between the two is the rapid arc, you can keep the wire outside the puddle, whereas the pulse, they like the wire inside the puddle. So for this one here, we're going to select number 12. For the metal thicknesses that we're going to be doing, we're going to be running an average voltage of about 19.5, and you can go below or above this by, say, 10 to maybe even up to 20%. If your machine is not showing the voltage and is just showing the trim values of 0.5 to 1.5, you can change that in the parameters. By doing the parameters, press these two buttons right here simultaneously at the same time. You'll get into the user preferences and go all the way to number 20 for the trim and volts, and we're going to change that. So we're going to press this button to select, and we're going to change this to yes, and we're going to press OK. It's changing the values. We're going to scroll back to 0 to exit. And that just changes our trim to voltage. That will be the average voltage as you're welding in pulse, which is the same as trim. A lot of people are just more used to the voltage. The wire feed speed we're looking at is probably about 190. So again, anything up, just a little bit below or above that. Into the machine here for our settings. And again, this is for the 035 wire that we're using, and it's an argon mixed here, and we're using a steel. So for in here, we'll press this button here for pre-flow time. We don't need any gas ahead of time, so we're not doing stainless steel, so we're going to just leave that off. This here knob does turn it, so you can adjust that. The run-in wire feed speed, so you can have the wire so it's running in slower, so not to stub hard when you're starting a weld. Generally, we'll just leave that off. The start time, this one here, you can have your maybe a hotter voltage and your wire feed speed here as well. So again, we generally don't do that, but to make for a nicer start, you can play with that. The spot timer here, how many seconds, and that is just how many seconds it welds for before it automatically turns off. So we don't want that on, so we'll leave that off. And the crater time here, it's kind of the opposite of the start. So at the stop at the end, it will continue to run for however many seconds at however voltage and wire feed speed as well, just to eliminate that crater at the end. And again, we generally leave that off. Burn back, it's nice to have this, so as you release the trigger, the wire will continue to come out, and this one here is 5/100ths of a second, so very little. You'll barely even notice that wire coming out at the end. Okay. And then from there, that's probably about the end of this here. Oh, post-flow time here. So post-flow is the very end, that's the gas that's at the very end here. And we don't need that, we're not doing stainless, so we don't need to have shielding gas over our chromium. And then from here we're back to the beginning again, the pre-flow. Press this button over here to return to the main screen, and then press this button again to see your ultimate arc. So the ultimate arc is, what this does is it increases or decreases the cone. So as you turn this up, it actually decreases the cone of the arc when you're welding. So what we're going to be doing, since we're going to be doing about 11 gauge, is we'll probably want to be up and around the 3. And again, you can play with this and look at this cone. So you want to add a little bit more because you want to narrow that up. It's not thick material, so it doesn't need to be wide. Okay. And then press this again to get back to the main screen. Okay. You want to make sure you're on A here or B, and these are just memory settings that could be set. And if it's in the middle, that means you can toggle in between the A and B as you're welding by clicking the trigger as you're welding. So we'll make sure this one here was on A. And then down over here you have the 2-step and the 4-step. Okay, you want to make sure you're on the 2-step so the wire starts and stops as you release the trigger. Otherwise this one here is a trigger lock. And that's what those ones are. Okay. So that gets you going here for the interface of this machine, and then we'll start to weld. The vices in the fab area are removable just by loosening this nut here. These do remove out to allow more room here on the table. And we're going to do some welding if it's in the way. These spatter shields here are located in the carts down below, just to eliminate any weld spatter onto the table that will cause any unnecessary cleanup after. And as you're putting these on the table, you can connect the ground directly to them, just so we eliminate any double arcing that could be happening through the table and up into the spatter shield. The guns here, there is a pipe holder here for the guns. We can put them in there like that. Also, these MIG guns here have a little hook on them, and we could hook them up there, something like that. So one thing we do not do is hook them onto a regulator or drape these over the machine like that. It's the last thing you're going to want to do, because if the trigger accidentally gets bumped, the wire will come out and we will get a big arc on the machine. And we don't want that, because that will leave a big mess. So again, just put those in there when you're done, and you'll eliminate having anything that looks like this on the side of your machine. When working with low carbon steel, we have a choice. We can have hot rolled material or cold rolled material. The cold rolled material has gone through a pickling process to eliminate the hard mill scale surface that is on the material through production. The hot rolled material is very weldable. You can weld right over that, and certain wires will burn through that better than others. But to eliminate the mill scale that's on here, we could power wire wheel this. So we can either do this beforehand, tacking everything together, so we can power wire wheel underneath and even in these sides before joining this together, or we can tack this together and power wire wheel it. Or we do not need to power wire wheel at all. It's just that when you have a cleaner surface, the weld puddle will just flow just a little bit better. So whether you power wire wheel or not, that'll be up to the application. It's just an extra step, an extra process. So whether you're doing a T-joint or a lap joint, an outside corner, or a groove like this one, again, you can power wire wheel or not and just weld right through. So before we start to weld, one thing that we're going to want to do is eliminate the buildup that was on the wire from the previous weld. So we'll be using our MIG pliers here and cut that on a 45. So that'd be a 45-degree angle there, and you're going to get a better start out of your wire. Okay, if we left that big blob that's on the end there, when you go to weld, it will kick back and it will leave lots of spatter and not have a very nice start. So this here is 11 gauge, and so whether you're welding in the flat, horizontal, or vertical up or down, or overhead, your travel angle is important. So as we're welding, we don't want too extreme of a travel angle. We want to be about 15 to 20 degrees off 90 degrees in the plate. And also our work angle, that would be this angle here, up and down. You're going to want to split that right in about the middle. So if you're welding in the flat here, that would be split there. You do not want to be leaning over to one side, because then all the weld will be coming up that side of the plate. So we want to make sure that we're perpendicular to the joint for our work angle, and our travel angle, we're going to be about 15 degrees back as we're going. An extreme angle will cause lots of spatter. The wire will be outside of the puddle, and then that hot wire hitting the cold metal will create a lot of spatter. So we want to make sure that we're not cold, we're keeping that wire in the puddle, and we're traveling consistently along the joint at a consistent speed and trying to keep the weld at a consistent size. Now for this here, at this gauge, we want to be welding as fast as possible. So a vertical down would be one of your fastest welds. And again, you're trying to cut that angle in half. And this one here, the travel angle is not going to be pointed down like this, but you're going to be pointing this wire up into the puddle. So keeping the wire in the puddle. And again, you're going to be about 15 degrees. And this one here will almost be like a dragging technique, because you're not really pushing the wire. The gravity is taking over and coming this way. So this will produce the smallest and the fastest weld for this size of plate. So anything that's 11 gauge or thinner is preferably just to go to a downhill, whereas a flat will sometimes take a little bit more heat of the plate, and it'll be not as quickly. The horizontal seems to work a little better than the flat sometimes, because the flat seems to want to take a lot of heat, whereas the horizontal will seem to just kind of move that weld along. But so whatever position that you decide to weld in, whether it be the beginners, generally the flat position is what we start with, or the horizontal, and then we get into the vertical. Biggest thing is being comfortable and being able to see where you're traveling. So making sure you're, looking underneath to see where the weld is. And that's the most important thing, is to be able to see and be comfortable and have the correct shade lens, and make sure you're not going to interfere or bump with anything along the way, so you have a nice smooth weld. For proper storage at the end of the day, I want to make sure that the power is turned off, the gas is turned off, and neatly coil up the MIG gun and the ground around the machine. Like this will be just fine. We do not like to coil around the regulators or the bottles or other parts of the machine, just so we're very neat and tidy and we're looking for something like this. So the next day we're ready to easily remove this off and start work.